Good afternoon. I'm Rouxel with DNV, and I'm going to talk about the wind resource measurement and siting for an offshore wind farm. So first, how do we come up with a wind farm layout, and where do we decide where it sits? That's really a two-phase thing. First, the, the government in the US, that would be BOM, but in different countries that would be a different entity, usually selects first which area will be leased to a developer for offshore wind development. So that's based on industry and state's need, environmental and economical constraints. That could be, for instance, a national park, a maritime park, or existing maritime traffic. For instance, shipping routes or intense fishing activity that would prevent the development of a wind farm, but also the wind resource, the water depth. So really, the selection of where the wind farm will sit is obviously driven by where there is wind, but it's just one factor among others. Unfortunately, we cannot just go where there is the most wind and develop it here. So then the second phase is when the government has leased an area to a developer. From this point, it's really the developer that runs with it. The developer is paying a fee, now a pretty big fee, and then they can lease this area of the sea for about 30 years. So the first thing they would do is first select technology, select a wind turbine technology, foundation that could be fixed or floating, an electrical export system. And then based on this, they will really try to optimize the area they have because it's limited surface and they will try to get the most of it. So it will be really a trade-off between putting as much wind turbine as possible within this area that would lead to higher capacity, but also more wake loss and less capacity factor. But then in the other side, they want to put as much as possible. So that will be really a trade-off depending on the average wind speed, the type of turbine. So that's a really important phase. And most of the time in this phase, they don't really have really detailed wind measurement data at this phase, usually because they just got the lease. They didn't have time to start a wind resource measurement campaign. So that phase is usually based on public data or existing data. But in the same time, they will also install a wind resource measurement equipment in the same time. So this wind resource measurement equipment could be of different type. Historically, it was mostly met mast, so that kind of fixed met mast installed on a fixed foundation on the seabed. It could be LiDAR installed on surrounding structure, so that could be an oil and gas structure if it's possible, but it's not always possible. Or more and more we use floating LiDAR, so that's a LiDAR, directional LiDAR installed on a buoy. That's much cheaper than a met mast, but we are also losing a bit of precision. So yeah, the real choice in most cases is really between the floating LiDAR and the met mast. The floating LiDAR, it's way cheaper, much easier to install, but there is also a bit more uncertainties. While the met mast is great because we have very good precision of the measurement with wind sensors are at different heights, but it's also way more expensive to install because you would need to install a monopile on the seabed. It's a pretty massive structure, at least 90 meters high, could be even higher. So then based on this wind measurement data, what we do is first we we analyze the data, which can be a quite time-consuming phase, because that would be basically identifying the errors of measurement, um, correcting the measurement. For instance, if it's a floating LiDAR, the LiDAR will move with the wave, so you have to compensate this wave motion. So it's quite a lot of data analysis to convert the measured data into a data that we can really use. Then we model the wind farm based on the layout we have developed. We model the wind farm, and then this way we can really model the energy that will be produced by each wind turbine, taking into account the wake effect, the specific power curve of each wind turbine. And then based on this, we can really have a precise wind production forecast, energy production forecast, and also estimate the uncertainties. This energy production forecast, and to have a really precise wind energy forecast, is really to be able to build the financial model for the developers, to have some certainties about how much energy they will produce, which means how much money they will get, and what is the level of certainty in this production. And that will be really important, first for the developer, but also for all the investors, like the banks that will invest in this project. So for the project to be financed, this piece is really a really important piece.